The following is a selected video from videomathteacher.com, where you can explore over 10,000 videos, print out practice worksheets, find proofs and discussions on many math topics, and explore related videos. Try videomathteacher.com today. Let's add the following fractions. We're given 7/12 plus 8/15. To add these two fractions, we'll change these two fractions into equivalent fractions with the least common denominator. Then, we'll add the numerators and write this as the result over the common denominator. To find the least common denominator for our fractions, we'll refer to the information on the right. The least common denominator contains the most frequent of each factor. So let's find the factorizations for each denominator, 12 and 15. To do this, on the right we'll use a factor tree. So for 12, we'll find two numbers that multiply to give us 12. That would be 3 times 4. But 4 can be factored to 2 times 2. So the prime factorization for 12, which we'll write as the denominator, will be 2 times 2 times 3, being the bottom leaves of our factor tree. Let's repeat this process for 15. So the prime factorization for 15 means finding two numbers that would multiply to give us 15, say 3 times 5. Both of these numbers are prime, so 15 will be factored to 3 times 5, which are the bottom leaves of our factor tree again. In our fractions, the numerators never changed, so we'll write 7 as the first numerator and 8 as the second. Again, the least common denominator contains the most frequent of each factor. So we'd like to find the common denominator between these two fractions now, and we'll write this as our next stage. The most frequent factors for the number 2 is we have 2 2's in our first fraction and no 2's in our second. Therefore, the common denominator will contain a pair of 2's in both fractions. For the number 3, the first fraction contains 1 3, and the second fraction also contains 1 3. So both common denominators here will also have a 3. Finally, our last fraction has a factor of 5. So both fractions will need to have a 5 in the common denominator. So the common denominator will be 2 times 2 times 3 times 5. Next, we'd like to change our fractions to equivalent fractions that contain a common denominator. For our first fraction, we already have a pair of 2's and a 3, but we need another 5. So we'll multiply our denominator by 5, and therefore multiply our numerator by 5. So the numerator will become 5 times 7. For our second fraction, we already have a 3 and we have a 5, but we need a pair of 2's. So we'll multiply the denominator by a pair of 2's, and multiply the numerator by a pair of 2's. So our second fraction will be 8 times 2 times 2. Let's multiply these numbers together. So for our first fraction, in the numerator, 5 times 7 is 35. And 2 times 2 is 4, 4 times 3 is 12, and 12 times 5 becomes 60. Plus, in our second fraction, 8 times 2 is 16, and 16 times 2 becomes 32. Our denominator again will be 2 times 2 times 3 times 5, which is 2 times 2 is 4, times 3 is 12, times 5 is 60 again. Now that we have two fractions that have the same common denominator, to add fractions, we'll add the numerators and write this over the common denominator. So adding our numerators, we'll write 35 plus 32 all over 60. And 35 plus 32 becomes 67 over 60. Our answer as an improper fraction would be 67 over 60. If we needed to write this as a mixed number, we would divide 60 into 67. So 60 goes into 67 one time. 1 times 60 becomes 60, and subtracting 7 minus 0 is 7, 6 minus 6 is nothing. So 7 becomes our remainder. And we could write a remainder as 7 over what we were dividing by, 60. So as a mixed number, this could be written as 1 and 7/60. So our answer as an improper fraction is 67 over 60, and our mixed number would be 1 and 7/60. This is our final answer.